Okay, so far you have learned to do a bunch of stuff in this unit, lots of stuff. So we have learned to combine like terms. So last Monday we did this lesson and it was things like, let's say you had 2x squared y plus 5x squared y, and you had to combine those like terms, and that combined to 7x squared y. So you've learned how to do that this unit. We've also learned how to multiply with the same base. So for example, let's say you had 3x squared times 8x cubed. So we know how to do that multiplication. Remember, we multiply the 3 and the 8 because those are just plain old numbers, right? So that would be 24. And then you write down the base and you add 2 plus 3. So this would be 24x to the 5th. Okay, and the first one was 7x squared y. So we learned how to do that last Tuesday. Then we learned how to multiply binomials. And you actually know like a bunch of different ways how to do this now. You know 3 different ways. The first way is the distributive property. The second way is the box method. And the third way is what we did yesterday in Desmos as a live class, and that is with the algebra tiles. So I'll do an example that shows all 3 of those ways. Let's see, what would be one that would be not too bad? How about 2x plus 1 times, we'll keep the numbers little, x plus 3. So it's not too bad. So the distributive property says that you would do 2x times x and 2x times 3. So this would be 2x times x is 2x times x. That would be 2x squared. And then if you did 2x, I'll do this one in green, 2x times 3, that would be 6x. Then now it's this one's turn. Remember how we did that? It's like the distributive property twice. So 1 times x is just 1x. And 1 times 3 is 3. Okay. So you combine like terms as much as possible, and your answer becomes 2x squared. These guys are the like terms, so you're allowed to add them. Don't do anything with the exponents, just add them. So the numbers in the front is what you add. So 7x and then plus 3. Okay. The box method, if I can squeeze it in here, might have to like kind of get over there into algebra tiles. So remember the box method, you make yourself a box with some dividers. Put 2x and plus 1 right here, and then x and plus 3 on the side. That's a little squished, isn't it? But we'll make the best of it. And then we'll make room for algebra tiles over there. So remember, you fill in the boxes by multiplying. So 2x times x, 2x squared. 1 times x is x. 2x times 3, 6x, and 1 times 3 is 3. Then you're going to add everything, and these guys on the diagonal always end up being the like terms, and you get the exact same answer. It's going to be 2x squared, 6x plus 7x, or I'm sorry, 6x plus 1x is 7x, and then plus 3. Okay? And then algebra tiles, well, that was in Desmos. Okay? So you had, oh my goodness, I will try my best, you guys, but I am not so good at drawing, so we shall see how this works out. I'll even try to use the same colors. So if we had 2x plus 1, that means we would have like 2 long bars, and need like an orange. I got like a peach color, that'll be good enough, and a 1 right here, right? So this was like x, x, and a little 1. And then if we have x plus 3 on the side, you'd have like a long one, there's an x, and then you'd have 1, 2, 3, like that. And they're all 1s. So then you would fill in everything. And so every time, this is the part that Desmos did a really nice job with, but every time you do x times x, that turns into a blue box, which represents x squared. And then when you do another x times x, you get a blue box. Now, when you do the x, the green x times the unit, Desmos made long, like long x's. And then that's what happens over here also. So you would have like a long x here and a long x here, here, here. Did I draw too many? X plus 3. So this would be like 1, 2, 3, 4, 5, 6. Oh, I drew too many over here. All right, y'all are probably looking at me like, what in the world? Why does she have that extra one over there? That's why. This should only have been one little square right here because it was 2x plus 1. Sorry about that, y'all. Okay, so because I was starting to draw this and I was like, oh no, I'm ended up with too many boxes. It's because I had an extra orange one over here. And then you would fill in with the remaining little orange ones. And so this is definitely not not perfect. And good news, you don't have to draw these for the test or the SOL. Desmos does a beautiful job of that, and you do not have to worry about that. You just have to look at multiple choice answers that are already drawn for you. So don't stress that. I just wanted to give you a little bit of a representation. So that's what we've learned so far. This is all so far Unit 6. And so we've done a lot of multiplying, lots and lots of multiplying, and a little bit of combining like terms. Okay, so today we're going to switch gears and we're not going to multiply anymore. We're going to do the inverse of that and divide. And this is where today's lesson comes from. So if we are dividing monomials, since dividing is the inverse operation of multiplying, you're going to do the opposite rule that you do for multiplying. So when you multiply, for example, x squared times x to the 4th, you add the exponents. 2 plus 4 is 6, okay? Oh, I also forgot to mention that we learned how to do power to a power also last week. So when you divide, your example is going to look something like this. Maybe it'll be x to the 8th power divided by, it's going to look like a fraction, x to the, maybe to the 3rd power, like that. So they're all going to look like fractions, but it's really just division problems, okay? Okay, so now you're going to keep the base, and instead of adding the exponents, you're going to do the inverse of that, which is subtracting. So it'll be 8 minus 3, which is x to the 5th, okay? So here's the big thing. I'm going to do it in like a different color marker so it stands out. Make sure that the bases are the same. You can only do this rule if you have the same variable on the top and the bottom. So like if you have x's and y's, you got to make sure that you keep the x's in the top and the bottom together and the y's in the top and the bottom together. Don't be subtracting exponents from different variables, okay? We can't mix and match with this. It's got to be the same letter on the top and the bottom, okay? And this works for numbers, it works for letters, it doesn't matter. I'll do another example for you. So like something you would see in the homework tonight. I think they use the number 5 in the homework. So I will use 5, but I'm going to use different exponents. So let's say we had 5 to the 10th power divided by 5 to the 6th power. So you have the same base, which is a 5. So it would be 5 to the 10 minus 6, which is 5 to the 4th power. Now, you might not see that as a multiple choice answer, and that's because they're going to actually multiply that out since it's just a number and not a variable. So that would be, excuse me, 5 times 5 is 25. 25 times 5 is 125. And then that times 5 is 625. Okay, so your answer would be 625. Are you still with me so far? Go ahead, give me like a thumbs up or a check mark if you're good to go, or ask me a question. All right, awesome. Thanks, guys. Good. So now let's just do a couple more and then I'm going to let you go and let you do your work. Okay. So let's jump to something that has 2 variables. So how about p to the 7th, q to the 16th, all over p to the 4th, q to the 12th. Okay. So notice, what is this teaching you? Like I always say, it's teaching you to be organized and observant. So you got to make sure that you keep the same variables together. So I'm going to circle these p's to remind me that I can only work with the 7 and the 4 there. And then I'll circle these q's to remind me that I'm working with the 16 and the 12, okay? This is definitely a unit that I love to use a lot of color with. So if you have like different color pens or markers or something, dig them out, use them, because it'll help you with your homework and on a test. So you're gonna put the variable down. So start with the p and then do subtraction. So 7 minus 4, and then the q, and then subtract 16 minus 12. So this simplifies to p to the 3rd, q to the 4th. And that's as far as you can go. You can't add the 3 and the 4 because these are 2 different bases. So this is complete. That is done. Okay. Remember, if I'm ever going like super fast, you can always just take a screenshot of your Chromebook screen and then save it to your files and either keep it or rewrite it later when you have time. So don't stress out if I'm ever like going too fast and you can't get it all written down. Just do a quick little screenshot. Okay, So now I want to try something that has some numbers in it. For instance, what if you had 6x to the 4th over 2x to the 3rd? Okay. So you've got some exponents, and then you also have just some regular numbers, okay? This 6 and this 2, that's just 6 divided by 2. There's nothing fancy going on here with exponents. You're not having to subtract, like don't do 6 minus 2, because that's not a subtraction problem, it's a division problem. So you're just gonna divide these. Just divide. Like Nike, just do it, just divide it. So all you have to do is divide that, which would be 3, okay? Don't forget what you already know. You know how to do division, so that's all you do with those numbers. The new stuff is with the exponents. So this is the new stuff with the x to the 4th and the x to the 3rd. So you're gonna put down the x and then subtract the exponents like that. So your answer will be 3x. You can put down to the first power if you want to, but you don't have to. You can just write 3x. Okay? Okay, last example. Try this one on your own. I'll give you like a little bit of time to work it out, and then I'll go over it and you can compare and see how you did. Try this one. This one's a challenging one, so be careful. All right, there we go. Try that one. I'll give you a few minutes to work on it and then I'll go over it. Oops, my paper won't stay. There we go. And when you feel good, like you're ready to go over this, go ahead and give me like a thumbs up or a check mark so that I know that you're ready. All righty, awesome. Okay, let's do this. So check your work. I'm going to start out by taking care of these numbers in the front. That is just a plain old division problem. Negative divided by negative is positive. And so negative 15 divided by negative 3 is 5. Now, I'm going to take care of the x's. So I have x on the top and the bottom, so this will be x raised to the 6 minus 5. Then I'm going to take care of the y's. So this becomes y raised to the 5 minus 3. Now, here's the one I want to see if you got this one, because a lot of people don't get this last one right. So be careful. The z's, I got a z to the 4th in the top, and it looks like there's nothing there for the bottom one. But there really is something there, right? There's a 1 right there. So don't forget that. Put that little 1 in there, just like we did for multiplication. We got to put it in there for division too. So this is actually z to the 4 minus 1. Okay? That's going to simplify to 5x y squared z to the 3rd. And that is completely and totally done. You don't have any more like terms, so you can't combine anymore. And that's it. Okay. Alrighty, I am gonna wrap up this lesson and let you go ahead and try your work. I'll leave the call open. If you need any help, feel free to say something and holler at me. And I hope that you have a great rest of your day.